Hello, my name is Sebastian Now, and today I will be proving the angle sum identity for sine. First, draw ray AB and rotate to point C, creating angle CAB, and let the measure of angle CAB equal x. Next, rotate further to point D, creating angle DAC, and let the measure of angle DAC equal y. Now, draw segment DE perpendicular to AB, and notice that sine of x plus y equals DE over AD. Next, draw DF perpendicular to AC, draw FG perpendicular to AB, and draw FH perpendicular to DE. Notice, HF is parallel to AB, and AC is a transversal to HF and AB. Therefore, angle HFA is congruent to angle CAB by the alternate interior angles theorem. Also notice that angle HFD is complementary to both angle HFA and HDF. Therefore, angle HFA is congruent to angle HDF, and the measure of angle HDF equals x, and this is because of the transitive property of equality. Now recall that the sine of x plus y equals DE over AD, and notice, the measure of DE equals the measure of DH plus the measure of HE, and the measure of HE equals the measure of FG. Therefore, the measure of DE equals the measure of DH plus the measure of FG. Sine of x plus y can now be rewritten as FG plus DH over AD. Now you can split the fraction into FG over AD plus DH over AD. And you can multiply each of these fractions by a form of 1. You multiply FG over AD by AF over AF, and multiply DH over AD by FD over FD. Now rewrite this side of the equation using the commutative property of equality. You can rewrite the fractions as FG over AF times AF over AD plus DH over FD times FD over AD. Finally, substitute sine and cosine values for each of these fractions. You will get sine of x plus y equals sine of x times cosine of y plus cosine of x times sine of y. And this is the angle sum identity for sine.